Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Semua okay? Everybody fine?
Alhamdulillah, fine.
Good.
Okay, today what we do first, we will do the quiz. Okay, I'm going to discuss the quiz, and we are going to grade the quiz. You are going to grade your quiz by yourself. So, bring up your quiz, because I'm going to give the solution. And then as we move on, you will grade yourself. All right? So bring up your quiz, and then we will discuss, and I will tell you how to grade. Okay? So that you know where you make a mistake, and then you give the points. Okay? Semua dah, everybody has the quiz ready? Not the quiz. I'm sorry. It's not the quiz. It's the homework. The assignment number 1. The question number 42 on the linear programming. Okay? The linear programming problem. So bring up that thing, and then we'll discuss, and then you grade your homework, and then you resubmit to me. Okay? Submit to me to the classroom, the one that has been corrected. Okay, so make sure when you resubmit, make sure the points are there, right? Give me the points so that it's easy on me. Okay, I'll make the points clear. Write in pen. Don't write in pencil. Is that done? So now everybody get the quiz. I'm sorry.
Yes.
I keep. Everybody got the homework. Okay, we will go into homework. Question number 42 on the serial problem. So the total marks for this one is 15. So the total points are 15. And as we move on, I will inform you, okay, the marks.
Oh, tak tukar baru lah.
All right. Question number 42. This is the homework. Okay, first, you understand what the problem is. You have the firm, okay, the cereal firm that produce 2 types of cereal. There is the senior citizen, okay, senior citizen, and then you have the kids, call it SG, KG, and then to produce each of these, they need the inputs, right? So you have your wheat and syrup, okay? And then for the kids, they need wheat, sugar, syrup. So here are the outputs, okay? These are the inputs. So we're going to make an objective, and then come up with the constraints, get the problem. Okay, so first thing, you can get the objective. Okay, you look at the question, you get the objective. What is the objective? Objective is to maximize profit. That. Okay, maximize profit, call it P, which is equal to AX plus BY. Now we need to define what is X. So again here, if you look at the profit statement, you can see, what are the variables, because they tell you to maximize profit. What do you have to do? So you can say X is what? So the profit is, or the variables are the cereals. Okay, so you let X be the senior citizen cereal, and the units are pounds, and then Y is the kids meal, also in pounds. So make sure you have the variables, okay, the X and Y clear. So it's up to you. It doesn't matter. You can say X is the kg, Y is the senior citizen. That does not matter. What is important is you assign a variable, because if you assign X as the kg, then everything will work accordingly. Okay, so that is not a matter. X must be senior citizen or Y must be kg. It can be the other way around. So from the statement there, or from the question, you will know already the variables. So what you do, you relate the variables, which are the senior citizen and the kids meal, to the inputs, all right? So which are the wheat, the syrup, and the sugar. And of course, this is X in pounds, this is Y in pounds as well. So you summarize this table, this information. What do we get? We get here 0.6, this is 0.2, 0.4, 0.2, 0.2. Of course, it is 0 lah. Okay. So based on this, you already have the problem. All right. The problem is what? The problem is to maximize the profit subject to these constraints. Okay, for those people who came in late, all right, we are going to grade the homework. So please take out your homework, do the grading. As I move on, okay, you do your grading, the homework by yourself. I'll give you the points. So you have the table already, and then you have the objective. So the problem is now maximize profit. So you have to state the problem. Otherwise, what are you solving? Okay. So the problem is to maximize the profit. Okay, profit. If you look at the profit, you can see the profit per unit of X and profit per unit of Y. Okay. So here, you can say, or you can see that A is equal to what? A is 0.9, and then B is equal to 1. So therefore, our profit function is simply just equal to 0.9x plus y. All right, subject to the constraints, which are 0.6x plus 0.4y. Oh yeah, we have not talked about the constraints. Okay, what are the constraints? I forgot to do that. The constraints on the wheat is how much? 2,800. And the constraint on the syrup is 1,000. Constraint on the sugar is 800. If you see the question, they say at most. Okay, the syrup at most. So at most means less or equal to. So there are common words, you know, at most. At most means that that is the maximum, can be lower. Okay, so less than. And the other common word we use is at least. At least means that's the lowest. It can be more, so bigger than. So if you look at the syrup, it's also at most. And then for the sugar, at least, okay? I'm sorry, for the syrup, at least. So bigger than. So you have two less than or equal to, and you have one bigger or equal to. So we summarize the constraints that would be equal to less than or equal to 2800. Here is 0.2x plus 0.2y bigger than 1,000. And then you have 0.2y less or equal to 800. Of course, you know, you have the non-negative constraints, x, y, are all or both bigger or equal to 0. This one, you don't have to, you know, this one, it's okay. You don't have to do it, because we know in application, we only deal with positive numbers. So this is the problem. All right. Now, the problem, if you have the problem, give yourself 2 marks. If you don't have the problem, don't give any marks. For the beginning part, where you come up with the table here, get the summary, get the variables, this is 1 mark. So if you don't have a table, you have the variables, then no marks. Okay, the most important is the table, where you come up with the what do you call it? With the information. So actually, this 1 mark is the table, all right, and the variables. Okay, table variables, 1 mark. And then the statement problem, 2 marks. All right, okay. Because I saw some of you, you didn't write the problem. I told you, write the problem. The problem is what? What is the problem? Because based on the problem, then only you can solve the question. So you got the problem here. You got the summary of the information. Now, if you don't have the table, you come up with the problem, give yourself 1.5. Okay, 1.5 marks. So make your own judgment. Okay, that's first part. Now, the second part, you want to draw the graph. Okay, so for drawing the graph, you need to find the corner points. So you need to find the equations. Okay, the equations, because I want to draw the graph. So the equations for the inequalities, you have number 1, 0.6x plus 0.4y equal to 2800. So you got the x-intercept. Okay, what is x-intercept? X-intercept means y equal to 0. So what is x? X is equal to 2800 over 0.6. That is equal to 466.7. So therefore, the x-intercept is 4666.70. And then you get the y-intercept, meaning x equal to 0. So you got 0.4y equal to 2800. Y equal to 2800 divided by 0.4, that is equal to 7,000. So that point is 7,000. Now you have to do it for each of this. Okay, I will just do this. The other one I don't do because I want to save time. So you do for the other one, same thing. Okay. Number 2, you got 0.2x plus 0.2y equal to 1,000. Okay, this one is simple, because 1,000 and then 0.2 and 0.2. So you get the x-intercept, you work it out, okay, find out. Here, I will just give you the final point. You get 5,000, 0. And then you get the y-intercept, meaning x equal to 0. You got 0, 5,000. Okay, show the work, okay? The work must be there. And then for the third equation, it's very simple. You got 0.2y equal to 800. So that means y equal to 800 divided by 0.2 equal to 4,000. So y equal to 4,000. All right? So y equal to 4,000. The y-intercept is 0, 4,000. And the line is a horizontal line. So this is the equation. Now for this equation, 2 points. Show the work, okay, for the 3 of them. If you just give me the final intercept, okay, no points. Because how do you get the point? Okay, the work must be there. Without the work, just the point, no point. Okay, the work and the point, correct, 2 points. Okay, any question, you let me know. So based on this, you draw the graph, okay? So you draw the graph. We can use an interval, thousands. So X is in thousands. Okay, Y is also in thousands. So I can use 1, 2, 3, 4, 5. And for the Y, since the highest value of Y is about 7,000. So I think I use 2, 4, 6, 8. Now for the graph, it doesn't matter what interval you choose. Okay, many of you maybe use 1 and 1. Okay, for the Y you got 1, 2, 3, 4, 5, and so on. For the X you got 1, 2, 3, 4, 5. So that's good. So I use 4. So you draw the graph of the equation. For the first one, what is the point, the intercepts are for the first one is 0.6x plus 0.4y, right? So the x-intercept is 4,6 something, so that's somewhere there. And the y-intercept is 7,000, somewhere there. So these 2 points, you make the connection. So I draw it. I hope I can get it right. Ah, cantik. So that line, okay, label it. 0.6x plus 0.4y equal to 800 less than. Okay, so less than, where is it? Down here. Okay, now the next line is the other equation, 0.2x plus 0.2y, 1000. So the first, or the x-intercept is 5,000, somewhere here. The y-intercept is, 5,000, 0. The y-intercept is 5,000. That's the point. You connect the points. Okay, good. I make it very, very nice. So that is the other inequality. So you got 0.2x plus 0.2y equal to 1,000. And then the other inequality is y equal to 4,000, or 0.2y equal to 8,000 or 4,000. 4,000 is here. Correct? Okay, now, where is the inequality? This inequality is bigger than, all right? So if you do bigger than, it should be the region up there. Okay, so that is the second inequality. Then you got y equal to 4,000. That would be that 4,000 is a horizontal line. So that is y equal to 4,000. And you need less than, okay? So less than would be the area below. So from here, you recognize the feasible region. Feasible region is this small area. Bordered by, you can label that point A, that point B, that point C. Okay, now this graph, 3 points. Okay, 3 points. 3 points consist of what? Consists of, number one, you have the intervals. You put the origin 0. You label your x. All right, okay? You label your y. And then you shade, okay? You shade the inequalities. That means for each of these inequalities, you show the region. So show, okay? Show regions. And then the feasible region, that one. From the regions, you come up with the feasible region. Okay, you get 3 marks. If, okay, because I saw some of you just show me the feasible region without the inequalities. So that is not enough, okay? That one give you 1 point, okay? The feasible region without the the inequalities region, only 1 mark, because this is more important. Okay, how you get the feasible region is more important than the feasible region itself. So if you have both of this, okay, that means 3 marks. If you just have the feasible region, only 1 mark. Okay, how do you get that region? You have to show how to get that region. Okay, so like I said, shade, okay, shade each of the inequality. So it doesn't matter like you use the same color or different color, or you can differentiate by yourself by using the direction of the shade. All right. So this is 3 marks. Okay. Any question? All right.
Question,
Good.
sir?
Another question? Okay. Go ahead.
Yeah.
Yeah.
Do we need to shape the entire region?
No, the entire region of the feasible region, or the entire region for the inequalities?
For the inequalities.
Not entire lah. At least, at least the area that we are working on. All right. You don't have to show up to ujung sana. Tak payahlah sampai ke bawah tu. Show kat sini je lah. Okay. Show for the area X bigger than 0, Y bigger than 0. At least that area. Tak payahlah semua area. Macam saya, in my case, I put a little bit to the negative. Just a little bit. And then I put also a little bit to the negative up there. But you don't have to put, you don't have to include the negative side. All right. What is most important is the area yang X bigger equal to 0, Y bigger equal to 0. Yang tu je. Not the whole area lah. The area so that give you idea, or make yourself clear in getting the feasible region. So that is most important. All right. Okay. So that is three points. Now you need to find the corner points. So next one is to find the corner points. Oh, I hope my internet is okay because it's unstable. So you have to find point A. Okay. So number one, you get to find point A. Point A is what? A system of inequalities, or a system of equations, I'm sorry. 0.2x plus 0.2y equal to 1,000. And then you have 0.6x plus 0.4y equal to 2,800. Okay, another thing that is important for the graph. Label the equation, okay? So it's okay, you write to the end of the graph, you label the equation so that you know which line is which, okay? Otherwise, it can be confusing later on. So just label it, okay? Label it with the arrow there so that you know the black line is that particular equation. So that is the importance of labeling. So from here, okay, call it 1, call it 2. So you can say from number 1, okay, from number 1, you will get y equal to 1,000 minus 0.2x divided by 0.2. So this is equal to, if you divide, you got equal 5,000 minus x. Okay, so the numbers are very good numbers. It's easy for us to work on. And then substitute into 2. So what do I get? I get 0.6x plus 0.4y, which is 5,000 minus x equal to 2,800. So you will get, okay, work it out. I will get x equal to 4,000. And then substitute into that thing, I will get y equal to 1,000. So that point A is 4,000, 1,000. So makes sense, huh? If you look at the graph, 4,000, 1,000, somewhere there. My graph is not very accurate. So it's about there, right? So that's why we need to find the point. Now for the points B, okay, for point B, that would be the system 0.6x plus 0.4y equal to 2800, and the horizontal line y equal to 4,000. Okay, this one very simple to do. You do direct substitution. What you will get is x equal to 2,000, y of course equal to 4,000. Okay, that's point B. So work this, show the working. And then to get the point C, same thing. You got the system 0.2x plus 0.2y equal to 1,000, and then y equal to 4,000. All right. So by direct substitution, you will get 1,000, 4,000. Okay, you got this? All right, all the three corner points with the working, okay? With the working, 3 marks. Okay, 3 points. If, okay, you just give me the corner points without any working, 0, okay? Just give me the corner points without working, 0. How do you get that? You can get it from the sky, or you can get it from someone without to do the working. So I don't want the answer. What I want is the working. Okay, the answer is not, of course, the answer is important, but the way to get the answer is very important. All right. So if you just give me A, B, C, the corner points, no work, 0. Okay. Show the work and the correct corner points, 3 points. If, okay, if you do the work, some of the corner points you get is wrong. Okay, so give yourself 2 points because the work is more important. Okay, sometimes you don't get the correct answer because maybe you do a careless mistake somewhere. Okay, so next time be more careful. All right. So without work, 0. With the work, some corner points you got it wrong. That's give yourself 2 points. Okay. All right. Good. So that is 3 points. And then we come to the final part of the question. Once you get the corner points, we tabulate the corner points. So the corner points, and then you got the objective plus y. Okay, so the point A is 1,000, 4,000. Point B, 2,000, 4,000. And then point C, 4,000, 1,000. So substitute into the objective, you will get 0.9, 1,000 plus 4,000. So that is equal to 4,900. And then for this one, I got 0.9, 1,000, 2,000 plus 4,000 equal to 5,800. And then 0.9, 4,000 plus 1,000 equal to 4,600. So as you can see here, all right, we want to find the maximum. So maximum value is that one. So that's the solution. So we say the maximum profit is $5,800. And to maximize the profit, all right, you have to sell the corresponding amount that will be denoted or that will be determined by the point. So X is what? X is the senior. So 2,000 pounds. I'm sorry, the units is in pound of the senior, and 4,000 pounds of the kids. So that is the conclusion. Now the table, 3 points. The conclusion here is 1 point. So that total up to 15. Okay. So I think for the table, if you get all the points, you will get the answer. Or if you get the points wrong, you still get the answer, but the answer may not be correct. Okay. So if you get the table and you got the one of the point wrong, so therefore your answers, some of them may not be consistent what it should be. Okay. So if everything okay, your work from the previous part was fine, and here you got a mistake because of the point that you got was different, so give yourself 2 marks. Okay, don't deduct too many points, deduct only 1 mark. Okay, without the table, no mark. Okay, without the table, no mark, 0. And then the conclusion is 1 mark. All right. Okay, good. So let's say, okay, suppose for point C, you got a different point. Probably you got 3900. Over here, you got 1500. But you show the working. Okay, if there was working, of course, this one you got wrong. Okay, but it's okay, because consistent from what you got and what you have here is consistent. So for this one, because that is not the answer anyway, so maybe give you 3 points. Okay, if you got a different answer, okay, that comes from a different point, that means it's wrong. So, but the table is there, the working is there, give yourself 2 marks. Okay, all right. Okay, any question, anything? So what you do, you sum your points, okay? You sum your points, and then put it on the top so that I can easily see your marks. So you sum all the points, give the total points on the top, okay? Top right corner, or on the top, okay? Or top right corner. Give your marks, write clearly, okay? Write clearly. Of course, after this, when I receive yours, I will go through also, just to make sure it's fine. So later, resubmit. Okay, resubmit the assignment 1 with the marks. Okay, any question? All right. So now what I want to remind you is this. I give you the time, okay? It's a deadline for the homework. If you submit after the homework, after the deadline, if you submit after the deadline, they will not grade it. Okay, your homework will not be graded. So if you get 0 and you say you submit, you get 0, that means you submit after deadline. So it is not graded. Okay, that's number 1. Number 2, make yourself clear. Okay, that means in your work, you write your name, your metric number of the group. That means yourself and your friend. And also, you write down who prepared. Okay, who prepared. Okay, who prepared. For the first homework, I don't see many people do that. Because why this is important, I want you to alternate. Okay, alternate taking the job of writing the solution. So if you do it for this one, the next homework, your friend will do the writing. Okay, so that is not always the case, one person has to do it. You have to share, okay? So just write down who prepared now, and then next time you alternate, say who is the one who prepared. All right. Any question? Anything? Okay, good. Okay, attendance. Again here, attendance, I look at the attendance. I have in this class 150 students. Today, people coming, many of you come late, 30 people coming late, but today attendance is 131. So I have, how much? 19 people missing. So if I look at every class, on average, more than 10 people missing, sometimes I got 15, sometimes I got 20, sometimes I got 10. So that, I think that is not good enough. If the people who are absent are the same people, I think you better drop the course lah. Okay. I don't think if you don't want to come to class, you will not learn anything, better drop. Okay, don't waste your money. But if the people who are absent taking turns, alternately, that's okay lah, because you can be absent a few times. So that, and I know, normally there'll be a few, not many lah, a few, 1 or 2 or 3 people who are the main people absent. But if you absent once in a while, that's okay. Okay? I don't have a problem with that. But if you start to be absent regularly, that is not good. So resubmit, okay? Resubmit today. The only people who need to resubmit are the people who already submit before the deadline, okay? So these are the only people who need to resubmit. And resubmit with the points. If you resubmit after the deadline, you don't have to submit, okay? If you submit after the deadline, you don't have to resubmit. If you don't submit at all, and today you want to resubmit, don't have to do it, okay? So it's only for these people who submit before or on the deadline. Okay, all right, thank you. So that take me almost half an hour. But of course, we need to discuss the homework question so that we can highlight, okay? You can recognize what are your mistakes, okay? So that from there we learn. So what I will do now, we will move on, to the next part. Like I mentioned last class, we will move on to 10.1. All right. Looking at the relationship between the derivative and the function. And then I will go back to chapter 9, the last part on the second derivative. And then we will, again, making use of the second derivative to look at the behavior of the function. So let us do that. So here, we want to see the behavior of the f prime and how it affects the behavior of the function. All right. In other words, the f prime or the y prime bigger than 0, less than 0, or equal to 0, it affects the behavior of the function. So that is what we're going to do now. So let's begin with this. Let me just draw a line, Let's say I got x and y. Let's say I have a line going like this. Y equal to f of x. Let me, if you look at the line here, you can see from the line, all right? If I take this point, say x1, what can you say about the derivative? Or if I take another point, x2, over that one. Okay, what can you say about the derivative or the slope over here? F prime here, F prime over there. Okay, what can you say? The common behavior here. Hello, hello. Are you there? Or is my internet
Yes.
rosak ke? Just look at the line.
It might be the same.
Before you say increase, what? Just look at the line here. What is the characteristic of this line here? Yeah, the derivative, or in other words, the slope.
Same, it's same, the slope.
Same slope, same slope. What do you mean by same slope?
Same derivative.
If you look at this point, okay, look at here. What can you say? Here is x3, this is x4. That one going like this, that one going like that. So what can you say? General character.
Same function.
Hurry up. Someone has to do it. Otherwise, I'm not going to continue.
The slope change from negative to positive.
So here is positive. Okay, over there,
From
negative.
negative to positive.
Okay, so this area here, or this point, x1 and x2, the f prime is positive. If you look at that point, the area or these 2 points, x3 and x4, f prime is negative. Okay, now, what does the f prime, whether it is positive or negative, tell you about the function? Okay, so that is what we're going to do. So now let's look at x equal to x1. And okay, dy dx, the derivative, is positive. Or you can say f prime, or you can say y prime. All right, now think of this as delta y over delta x, so that it can make more sense. Okay, so here you got the slope negative, positive. Okay, I'm sorry, positive. If x increased by 1 unit, say 1 unit, then what about y? If the slope is positive,
The change is in y is positive.
the x also increase. All right, I mean the y increase. So if x increased by say 1 unit, because 1 unit, something that you can imagine, what about y? Y will increase, okay, by whatever the amount which is given by the derivative or by the slope. But the point is y will increase. Okay, well, increase by how much? By the amount of the slope lah. But that is not important. What important is you want to see whether the function or the y is increased or not. Okay, so that means if the slope is positive, you will have, okay, if x increases by some unit, what about the y? The y will increase. So what is our conclusion? Our conclusion is simple. If, okay, y prime or dy dx is positive at x equal to x1, that means the function is what? The function is increasing. Okay, the function is going up. All right, so that will be true for any point where the derivative is positive. It's true at x2, it's true at x1, so it is true at any of these points. Okay, so generally at any x, okay, at any x, if dy dx or y prime is positive, what can you say about the function? The function is increasing, okay? The y is going up, all right? So, of course, the y is going up by the amount of the slope, okay? But now we are talking generally, so we just say that the function is increasing. All right, so go back to the other side. As you can see, at x equal to x3, the derivative is negative. So what does it tell you about the value of y? If x increases by, say, 1 unit. So here you got dy dx or y prime is negative. Now think of it as delta y over delta x. So if x here increases by 1 unit, then what happened to the y? Because the slope is negative. X increased, what happened to y?
Decrease.
The y will decrease. Okay, the change in y will be less than 0. In other words, y decrease. Now, when y decrease, that means the function decreases. Okay, so if you look at the point again at x3, that means if x increases by 1 unit, all right, x increases by 1 unit. So in other words, x increased by 1 unit, that x will go that way. Okay, x increased from x3 to the other point. So the delta y is going down. So the function will go down or y will decrease. So our conclusion is this. At any x, not just x3, if, okay, the derivative at that x is negative, then what about the function? The y is going down. In other words, the function will decrease. Okay, so negative slope at any point indicate the function is going down. All right. Positive slope at any point indicate for an increase in x, the function is going up. Okay. All right. Any question about that? Because this is a very basic and important relationship. Now, as you can see here, there will be 1 point. There's 1 point, okay, in this graph. 1 point here. The slope is equal to what? Equal to 0. So that point, call it x0. Okay. So you got the slope here, x. The slope dy dx is equal to 0. Now, if the slope is 0, derivative equal to 0, f prime, y prime equal to 0. If x increases by, say, 1 unit, what happened to the y? If x increases by a small amount, what happened to y? If the slope is 0? The y will increase or the y will decrease?
No change in y.
No change, okay? The y will stay the same, okay? So the y will stay the same, the y will be there. So the third characteristic relationship is at x equal to x0, you will see dy, the x equal to y prime equal to 0. Okay, now think of it as delta y over delta x. For an increase in x by a small amount, what about y? Y do not change because the slope is 0. Okay, y don't change. That means delta y is 0. Okay, so do not change. We call that the stationary point. All right, x0, of course, that will correspond to some point y0. But the thing is here, at any x, all right, if the derivative at that point is equal to 0, that means y don't change, or the function will be stationary. Okay, that means don't change. Huh? And we call that point stationary point. Sometimes you call it critical point. All right. Anybody, any question? So these characteristics and the behavior is important. All right. If the derivative is positive, that means y is increasing, and the other way around. Now, what you have done so far is just looking at the point. But if you look at the function again, where the derivative is positive, it's not only at one point. Okay, it's a lot of points from here, up there, all the way up to infinity. Okay, for all the x over here, the f prime is positive. Okay, and if you look at the other side, all these points, would be what? Would be f prime negative. So if you look at this area or this curve, we can break it down, okay, into intervals, okay, into intervals, so that they will be consisting of too many points, okay, too many values of x that show a consistent sign of the derivative. So you can break it out into an area or the points or interval for which the f prime is positive. And then you have another interval, the different values of x, for which the f prime is negative. Because it's not just one point, it is consisting of all the points. So look at the graph again. From where to where? All right. Thus, the derivative is increasing. Just give me the value of x. Don't worry about the value of y. From what point of x to what point of x do the f prime positive? Just look at the graph. From where to where? Okay, so next you want to find intervals, all right, for which the f prime is positive and the f prime is negative. And of course, f prime is 0, all right, because there are so many points. So for the f prime is positive, from where to where in terms of the values of x? The initial point, the final point. Where is it? Look at the graph. Give me something. Okay, tell me. Anybody? Okay, yeah. From where to where? Or from what values of x to what value of x does the f prime is positive? From where to where?
x0 to infinity.
It's from, okay, it's not x0. X0 is not included because what is the slope at x0? At x0, the derivative is 0. Okay, so it must be a point not including x0, will be somewhere there. All right, call it whatever the value, okay, but does not include x0. So the interval that we're talking about, where the positive derivative is from x0 to infinity. Now, when I put the bracket like this, that does not include, okay, not included the initial point. So does not include x0, okay, because at x0, the derivative is 0. So you call it the critical point. All right. So from x0, you just call it x0, but you indicate by that bracket. If our bracket is like this, then it includes the initial point. If the bracket is like we have now, that does not include the initial point. It includes any other points bigger than x0. That means x0 plus 0.0001. Okay, that is already included in the interval. Similarly, for the values of x, for the interval for which the derivative is negative, where does it start from and where it ends? Go back to the graph. From where to where? What is the last point? So you start from the left, okay, from the smaller value up to the highest value up there. So the interval is from negative infinity, because there are so many points. So the range is from infinity, negative infinity, up to x0. And x0 is not included because x0 is the critical point. Okay, so now we know at any interval, okay, at any interval, the behavior of the derivative is consistent. All right, so in this interval, f prime is positive. In this interval, f prime is negative. So in each interval, the derivative is consistent, either positive or negative. Of course, you may have some undefined, but we don't worry about that. We worry only about the nice behavior. Okay, so we will not have interval for some area or some points is negative, some points is positive. If you have that, break it down again into 2 intervals. Okay, so bottom line is for each interval, the f prime behavior is consistent, either positive or negative. And there is one point, we call it critical point, where the f prime is equal to 0. Okay, any question about that? Okay, next. If you look at the graph again, the critical point is in the middle, okay, in the center. So if you look at the point, if I can draw the x, the values of x, I got here x0. Okay, no, don't worry about the origin. We just worry about the critical point. So that is where the f prime is equal to 0. To the right over here, I got f prime positive. To the left over there, I got f prime negative. So if you can see here, the critical point is important. Why is critical point important? Why is that x0 important? When you look at the behavior of the f prime, okay, and as you know, you break it out into f prime positive, f prime negative. Now, why is this point important, where the derivative is 0? Huh? Anybody? Why is it important? The critical point is important because that would be our, what you call it, our critical point, or the point, okay, that will be the point that will determine the intervals. Okay, that will be that determine the intervals. So based on the critical point, that will determine the intervals. Okay, you have here the critical point is x0, where the f prime is equal to 0. So you know that is where the f prime is equal to 0, critical point. So therefore, there will be 2 intervals. One to the right of x0, the other is to the left of x0. Okay, and here in this example, f prime is positive, f prime is negative to the right and to the left. Okay, all right. Now that will determine the interval. So let's look at another example. Okay, suppose I have another line. Okay, I draw another line. Say it be like this. Here I got y equal to g of x. Okay, if you look at this line again here, where is the region? Okay, the slope is negative. Is it on the left or on the right?
Left. On the right.
On the right. Over here, slope's negative. Okay, what about here? Slope positive.
Positive.
Okay, and you know, one point here, the slope is 0, or y prime is 0. Suppose that will happen at another point, we just also call it x0, okay? Or maybe call it x1 because x0 is over there, all right? So you got that critical point, okay, where the f prime is equal to 0. And there are two intervals, one to the right, one to the left, okay? But in this case here, the interval to the right, the f prime is negative. The interval on the left, f prime is positive. Okay, so if you go back to the number line that I just drew, I have here another situation. The critical point, call it x1, f prime is equal to 0, and then you have two intervals to the right, one interval to the left. Okay, so here y prime equal to 0. So I got the interval here is x1 to infinity. This interval negative infinity to x1. And from the graph, f prime here is negative, f prime here is positive. All right? So the important point here is the critical point, okay, will determine the intervals. After you determine the interval, then only you look at whether the derivative is positive or negative. Okay? Here, f prime is positive. Over here, f prime is negative. So that will come later. Okay? We determine the interval first. And then you will see whether the f prime negative or f prime positive. So from the behavior of the f prime, if, okay, f prime is negative over that interval, what can you say about the function for that interval? What can you say about the behavior of y or the behavior of the function? Increasing or decreasing?
Decreasing.
Huh? Decreasing. Okay, the function is decreasing. And the f prime here is positive from the interval negative infinity to x1. What can you say about the function? Going up or going down?
Going up.
Going up. The function is increasing. Okay? So you look at the other example, f prime is negative. That means what? The function is decreasing. F prime is positive, function is increasing. So from here, you can see how the curve behaves, okay? Which is consistent with the picture that we have, okay? So if you look at the first graph, the critical point is x0. To the right, where the f prime is positive, you can see the function is going up, okay? And to the left, where the f prime is negative, you can see the function is going down, okay? So that we can relate, okay? And the second example, critical point is x1, and you see the interval to the right, x1 to infinity, the f prime is negative. F prime to negative indicating what? Function is going down, function is decreasing. So the curve is going down, as you can see. And the interval to the left, negative infinity to x1, f prime is positive, you know. So what happened to the curve? The curve is going up. So That is the relationship. Any question? Now, this is very important because this is the basis, okay? This is the basis of this derivative test. So if you look at the first example, the curve here, okay, the function is going down. And then, of course, that is the critical point. After that, it goes up, okay? Okay, and then, of course, how do you get that? You can show it from the behavior of the derivative. Okay, all right. Any comment, any question? Okay, good. So now, based on this relationship of the behavior, we can, given the equation, okay, given an equation, we can draw the graph. We can sketch, not really draw, because you don't need to find all the points. We can sketch the graph of the function by first derivative. Okay, by first derivative, that means f prime or y prime, and how it determines the behavior of the function, whether it is increasing or decreasing or stationary. Okay, so we can do that. Or given the equation, we can find the intervals. Okay, the intervals for which the function is increasing, decreasing, stationary. Okay, and then we can sketch the graph. Okay, how do we do that? Okay, this is the method. Okay, given an equation, y is a function of x. All right, so what you do first one is that you have to find, because the critical point is the one that determines the intervals. So first thing that you do, you need to find the critical point, where y prime equal to f prime of x equal to 0. So this is the thing that you need to find first. All right. So say that point is equal to x0, y0. So you got the critical point. We don't have to worry too much about the y. We just worry about the x because we want to see the behavior of the function. So based on the x equal to x0, I can draw just the x, because the x line. So that is x0, f prime 0. Okay. So now, how many intervals can we break it up for this equation? I have critical point x equal to x0. So how many intervals do I have?
2.
2 intervals. Okay, one interval to the right, one interval to the left. We already know this. Okay, now suppose I have 2 critical points. 2 critical points. After you find the critical points, there are 2. Say x0, y0. And then another point is x1, y1. So let me just draw the x line. X0 is here. Say x1 is there. Now this will break the intervals. Okay, based on this graph, based on this picture, how many intervals do we have? Or how many intervals it is broken
3.
into? Okay, do the interval. What are the intervals? Give me the first interval.
Negative infinity to x0.
Okay, first interval is from here, negative infinity, x0. Okay, next, second interval.
X0
x0
to x1.
x1.
The second interval, x0, x1. Okay, third interval, x1
X1
infinity.
infinity.
Okay, so from here you can see the critical points, regardless of how many of them, okay, that will break out into intervals. So as you can see, one critical point, there are two intervals. Okay, you have two critical points, there will be three intervals, right? One is definite interval from x0 to x1. The other is very big area, a very big critical point, very big interval, x1 to infinity. And of course, if you have three, you have more intervals. So that is first step, all right? First step is you find the critical point, because from the critical point, you can break out into intervals. Now, number two, how do you know? Okay, how to know which interval derivative is positive and which interval the derivative is negative. So what we do here, for each interval, you want to test, okay? You want to test whether it's, the derivative is positive or negative. So you take one test point, okay? You take test point to test whether the f prime is positive or the f prime is negative, all right? Now, say I take a point, all right? Before we do that, of course, we look at the intervals. Say for take one test point before I say for each interval. Okay, for each interval, take one test point. So I have two intervals from negative infinity to x0. So it's good that we can make a table. All right, so here are the intervals. And here is the f prime. And of course, you want to look at the function as well. And then x0 infinity. Now we need only to take one test point, and that will be the same behavior of the interval. So one test point, you will generalize. Okay, generalize to the interval. So you don't have to worry, because as I said earlier, in one interval, if the prime is positive, it will be positive for every point in the interval. All right, so we just need to have only one test point. So let's say for x, for this interval, I take x equal to x1, whatever the value is, okay? And you test, all right, whether f prime is positive or f prime is negative. And then you make the conclusion accordingly. Similarly, for the second interval, say I take one test point, x equal to x2. Again here, check whether f prime is positive, f prime negative. And from there, you can see how the function behaves. And also from here, you can say how the function behaves. Okay? So that is the method. Once you do that, then you can say, or you can conclude about the behavior of the function. Okay? And you can sketch the graph. Okay? You can sketch, and then you can look at the graph. Okay? So that is the method. And we call this method first derivative. Okay, I will name it afterwards. Basically, we're going to make use of the first derivative. Okay, so we call it first derivative test. Okay, any question? Okay, I have a few more minutes. So let's consider an example. So suppose we will have the example. So suppose you got example, call example number 1. I have y or f of x equal to 3x squared minus 5x plus 20. All right, suppose I have this function. You want to find, all right, I want to find the intervals for which the function is increasing, decreasing, and then sketch the graph, sketch the curve. Okay, so we are going to make use of the first derivative test. Number one, what do I need? I need to find the critical point. Okay, critical point or points, because it can be more than one. And as you know, critical point, y prime is 0. Okay, so what you do, you take the derivative of y. So what do I get? I get y prime equal to what? Equal to 6x minus 5. Okay, now y equal to 0 for critical point. That means I got 6x minus 5 equal to 0, x equal to 5 over 6. And that is equal to, anybody has calculator? What? Cepat sikit. Berapa dapat? 5 over 6 berapa? 0 berapa?
0.83.
0.83. Okay, so that is our critical point, critical value of x. Of course, here you can find the y0. All right, find the y0, but we do it afterwards. We want to focus on the x because I want to find the area for which the derivative is positive and negative. So you have, if you want, but you don't have to do this. Because once you know the critical point, you can automatically break it down into intervals. So I have here 5.5 over 6, or 0.83. So that will determine your interval. One to the right, one to the left. Okay? Okay. So based on the critical point, I have two intervals. So we tabulate the intervals. One interval is from negative infinity to 0.83. The other interval 0.83 to infinity. And of course, here you want to find the f prime, and then you want to look at the behavior of the function. And again, you get to get the test point. Okay, just give me one test point. So if you look at the interval, the critical point is at 0.83. Okay, give me one test point to the right interval.
1.
1.
1. Okay, 1 is a simple number, very easy to do. So you take 1. So interval, for that interval, you take test point x equal to 1. And then you substitute into the f prime or y prime, right? Equal to 6x minus 5. So 6 multiplied by 1 minus 5 equal to 1. Now 1 is positive. So the derivative is positive. Derivative positive, what does it tell you about the function? Going up or going down? Increasing or decreasing?
Going up.
Increasing or going up?
Increasing.
Okay. Now, go back to the other interval. You have 5.6 or negative infinity to 0.83. Okay, what test point do you want? Yeah.
0.
Bagus. 0, pandai. Okay, ambil test point. Take the simplest. Okay, in the simplest available. Jangan buat kerja susah. Okay, senangkan diri. X equal to 0. So y prime equal to 6 multiplied by 0 minus 5. That is equal to negative 5. That is less than 0. So what about the function?
Decreasing.
Decreasing.
Okay, so decreasing. Decreasing, critical point y prime is equal to 0. After that, it's increasing. So from there, you can have idea how the curve look like. You can sketch the graph. So when you sketch the graph, what we do here, you just have X and Y. You don't need the interval, all right? What we need is only the critical point. Critical point is 0.83, but I don't know what the value of Y, okay? So can you find the value of Y when X is equal to 0.83? Berapa? Anybody? 0.83.
Negative 0.02.
Berapa dia? Negatif?
Number is
Negative
under
0.02.
reference, right?
Berapa? 0.02.
Negative 0.02.
Negative 0.02. So the point is negative 0.02. Everybody got it? Betul? Ada yang bagi saya nampak salah ni. Dia betul? Everybody got it? Okay. So somewhere here. Katakan ini 1, ini pun negatif 1. So that means to be somewhere here. We need the location lah. Okay? We need that thing. Roughly. Okay? Rough location. So that is the critical point where the slope is 0. And then if you can look at the graph from the left, all right? If you know the interval on the left, the function is increasing. Okay, the derivative is positive, so the function is increasing. Okay, I think my graph doesn't reflect the behavior very good because of my spacing. So I thought, you know, it goes downward and or it goes the other way around. So tak apa, we draw another graph to reflect the actual curve. So what you do?
So from left, it's decreasing.
From left?
Decreasing. The test point x equal to 0. The
you know
first
what?
derivative is negative.
Kita buat terbalik belakang tu. X equal to 1. Ni salah ni. Betul tak? Apa saya tak cakap tadi? Ayah. So that interval is wrong. Is that right? The test point tu correspond to the other interval. So tak apa, kita tukar je.
Yeah.
Terbalik kot. Apa saya tak bagi tahu tadi, dia nasib baik saya tak draw apa? Terbalik kot. So x equal to 1. That means the interval is from 0.83 to infinity. Betul tak? Dah tahu siap-siap buat silap. Cakap lah Wawan. Lain kali beritahu Wawan. Jangan beritahu dah siap gerah pun cakap. I was thinking we are on the right interval. But actually it was the other way around. So your job is not only to follow me, okay? Your job is also to check, all right? If I make a mistake, let me know. Jangan main diam ya. The teacher is not always correct. So ini negatif, yang tu sepatutnya the other way around lah. Okay, negative infinity to 8, 3. All right. So my graph actually was correct lah. Tak apa, we draw another graph.
Sir.
Yeah.
To sketch our graph, the critical point is 0.83 and 0. Y is 0, not negative 0.02.
The critical point inilah dia. 0.83 x. The value
Zero.
of y is 0.02.
Y is 0.
Bukan 0. You know why it's not 0? Because you have to substitute the x equal to 0.83, okay, into the function, into y, not into y prime. Okay, we don't want the slope. You want the point where the slope is equal to 0. So you substitute into the y, the function. Okay, which is equal to, berapa tadi? 3x squared minus 5x plus 20. Okay, masuk into kat ni tu, bukan masuk dalam y prime. To get this, then you got negative 0.2. That y prime equal to 0.
We get the
That is the slope.
difference, sir.
Apa dia?
Not negative 0.02, sir.
17.9.
Yeah,
17.9. Okay. Okay, betul kan? 17.9 Alright.
Yes.
So that's the
Yes,
correct
sir.
point. Okay. You don't put into y prime. Alright? Because y prime is the slope. We don't want the slope now. Okay? You want the point where the slope is 0. So I want the point xy where the slope is 0. So you substitute into the function. So I got you got 0.83, 17.9. Okay. I have a few more minutes, 1 more minute. So you draw the graph. Lebih kurang lah, you know, x, y, 0 here, y here. 0.83 and 17 will be somewhere here. Jauh here. Will be somewhere there. Okay. Now, if you look at the table again, for the interval from the left, okay, negative infinity to 0.83, the function is decreasing. Derivative is negative. Okay, negative derivative. Function is decreasing. For the interval 0.83 to infinity, the derivative is positive. Function is increasing. So you can sketch the graph. Here, you know, the positive, the slope is positive 0. So here it's going up. All right. From there, it's going down. So you got y equal to 3x squared minus 5x plus 20. And the critical point is, of course, 0.83, 17.9. So from there, you got the graph. So you can see, you know, from the equation, by making use of the derivative, you can determine the intervals for which the function is decreasing or increasing by the derivative. And from there, you can have idea how the curve look like. Okay. So what I mean here by sketching, you don't need interval. Okay. No interval. And you don't need the intercepts unless the question asks you for intercept. So intercepts not needed. What is needed is the critical point. Okay. Roughly the position. Janganlah 0.83, 17.9 you hentam kat sini. Yeah. Itu tak betul lah. At least the location is somewhat accurate lah. Okay. So that is why you need the critical point, so that you can make the location of the critical point more accurately. Okay. All right. So what we do here is 10.1. I would like you to do some questions, okay, for your practice before we leave. So go to 10.1. I will give you a few questions, you know, where you will find the critical point and then you sketch the graph. So I would like you to do some questions on the homework. Okay, do number 7. Ui, susah ni dia bagi. Okay, number 7, number 21, 22. Actually, 21 itu kita bagi banyak lagi. Number 7, and then you do number 15. Okay, 17, 21, 22. Okay, so these are some questions. Just practice, all right? Get the critical point and then break out into interval and things like that. Now, actually, when you draw this graph, you recognize, you know, some point, a point that is maximum, minimum. So we continue, you know, an extension from here next class. to conclude or to relate whether the critical point is a maximum or minimum. So that is for the continuation of what we were discussing now. Okay, all right. So next class, next week, okay, next week, I will discuss about the second derivative. So that second derivative is 9 point something. And then we will come back to chapter number 10. And we're going to do this test again, okay, by using the second derivative. So I'll see you again. Have a nice weekend. Take care of yourself, all right? Now COVID-19 is stabilizing, but take care, okay? If you stay in Sabah, be more careful. If you stay in Selangor still okay lah. All right? So I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you, sir.
Jangan lupa resubmit tau.
sir.
Resubmit that homework, alright?
Thank you,
Submit the homework
sir.
with your mark. Okay.
sir.
Okay, thank you.
Okay,
Alright, I'll
sir.
see you.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Jadi cakap, awak lagi nak fikir.